Good morning to all. Introduce myself, K JANAKI, Assistant Professor, Department of Mathematics, JJ College of Arts and Science, Pudukkottai. Today my topic is Introduction to Parallelogram Law of Forces, handled by the 3rd BSc Mathematics. First, we have to discuss about what is statics. Statics is the branch of mechanics. Mechanics is the science that deals with the action of forces on bodies under the influence forces. Bodies may be either in motion or at rest. That branches of mechanics which is concerned with the condition under which bodies remain at rest when acted on by forces is called statics. Statics is actually the application of mathematics and basic physics to study forces in materials, machines, and structures. Statics is the branch of mechanics. Mechanics is the contained in physics. Mechanics is physical science that deals with the response to bodies to the action of forces. Action of forces. Forces may be defined forces as any cases which produces or tends to produce a change in the existing state of rest of a body or of its uniform motion in a straight line. A forces will be completely known its magnitude, its direction, and its the point of applications. That is the point of the body at which the forces acts in the straight line. That this is represents a vector denoted as AB vector corresponding to the point A and B. The forces are three types. First one attraction, second one tension, and third one reaction. So the another one is equilibrium of forces. The equilibrium of forces means a number of forces act on a body and keep it at rest. The forces are said to be equilibrium. So mechanics is the branch of physics. Statics and dynamics and fluid mechanics is the branches of mechanics. Scalar quantities are used in statics. Vector quantities are used in dynamics. The scalar quantities are length, mass, time, speed, volume, density, energy. This is represented magnitude only. And the vector quantities are displacement, force, velocity, acceleration, moment. This is corresponding to magnitude plus direction. And length or calculated small r, and also displacement is r. Speed and velocity are both small p. Then next, what is parallelogram law of forces? Parallelogram law. The parallelogram law is the sum of the squares of sides of a parallelogram is equal to the sum of the diagonals of the parallelogram. That is, the sides are AD, DC, CB and AB. So the square term, sum of the square terms of the sides is AB square plus BC square plus CD square plus AD square, that is equal to sum of the squares of the diagonals. The diagonals values are AC square plus BD square. This is the use. This is the uses of parallelogram law of forces. So the one point fixed 0. The forces are acting on that point. The forces are F1 and F2 acting on the points P and R. That is contact of the point Q. Draw the lines. We have to draw the parallelogram PQ or O or OPQR. So the F1 forces acting on the side OR and the F2 is acting on the side OP. Then the resultant of the forces acting on the side OQ. Okay, so the resultant of the forces is denoted by capital F or capital R, that is equal to F1 plus F2 vector. So this is This is normal f1 plus f2 equal to capital R is the parallelogram law. So this is substitute and using this parallelogram laws, that is equal to corresponding to theta and the forces f1 square plus f2 square plus 2 into f1 into f2 cos theta equal to the um, diagonal side square qs the whole square. This is the parallelogram law of forces, and yeah, that is p and q are the forces, r is the resultant. Then the formula is capital R equal to root of p square plus q square plus 2pq cos alpha or theta, and also tan pi equal to q, tan pi equal to q sin alpha divide p plus q cos alpha. This is the vector addition and subtraction. This is used for parallelogram law also. Magnitude V equal to modulus of V. Parallelogram law equal to R equal to A plus B. Triangle rule also. R equal to A plus B. Subtraction. R equal to A minus B. See the figures. Parallelogram law of vector addition, a plus b equal to qs. So using this for parallelogram law of forces, so f1 equal to a, f2 equal to b, sub in the formula modulus of a square plus modulus of b square plus 2 into modulus of a into modulus of b cos theta, that is equal to qs square. See the figure. This is three special cases. First one is theta equal to 0, sub in the resultant and angle formula. So cos 0 degree equal to 1, sin 0 equal to 0. So the resultant of the force is f1 plus f2, and then next alpha equal to 0 degree. Sub in the formula, and the case 2 theta equal to 180 degree. Sub in cos 180 degree equal to minus 1, sin 180 degree equal to 0, sub in resultant and tan by formula, tan alpha formula. Then we have to we get f equal to root of f1 square, f1 plus or minus f2 the whole square. Alpha equal to 0 degree or 180 degree. The case 3 equal to theta equal to 90 degree, cos 90 degree equal to 0, sin 90 degree equal to 1. So the resultant of the force is f equal to root of f1 square plus f2 square, and then alpha equal to tan inverse f2 divide f1. This is the Cartesian vectors or rectangular vectors. In the Cartesian plane, x, y, z, x and y is normal, acting on the forces P and Q. The V, capital V is the resultant of the forces acting on K vector. The Cartesian unit vectors are I, J, K. Cartesian components are corresponding to the plane V equal to V of Vx, Vy, Vz, that is equal to Vx I vector plus Vy j vector plus Vj k vector, that is equal to resultant of the vectors. The direction cosines A equal to Vx divide modulus of V. This is the formula. We got to add all the components and all the components, subtract all the components. For example, see the diagram. A and B are forces. The values are 8 and 12. The angle of values equal to first one 45 degree and second angle is 30 degree. Sub in the formulas. A equal to Ax I vector. Unit vectors are I and J. So capital A equal to 8, capital B equal to 12 is sub in this formula. A resultant is Axi vector plus Ayj vector, sub in values. So 8 cos 45 degree I plus 8 sin 45 degree J, sin 45 and cos 45. Sub values, sub in this term, we get A and B. So a plus b equal to 16.05 I vector minus 0.35 j vector. To calculate the magnitude of the a plus b, that is equal to 16.05. So the direction angle is theta equal to tan inverse of minus 0.35 divided 16.05, that is equal to minus 1.25. Thank you.